Good afternoon, everyone, and thank you for joining our webinar today. My name is Carrie Williams. I'm the Director of Marketing for Test Oil. I'm very pleased to be hosting this webinar today, but before I start, I have to do a little bit of housekeeping. I need to check my audio. So if you can hear me, can you please locate the toolbar from the GoToWebinar application and raise your hand. So you click on the little hand button. I see I'm getting some hands. Okay, it looks like my audio is working. Well, that's great. Just so you know, we have more than 100 people registered for this webinar today, so I am recording the webinar. I have you all on mute to ensure that we have a high-quality recording. If you have any questions during or after the webinar, you can use that toolbar. There is a question section towards the bottom, and you can submit your questions there, and at the end of the webinar, I will ask them for you, and we'll get you some answers. If we run out of time, or if your question seems a little too complicated, I will save it for later and have our speaker address your question through email. So with that, I'm going to go ahead and get started. Our webinar today is titled Condition-Based Oil Changes, an Easy Way to Save Big Money. And it is being presented by Brian Thorp of Seminole Electric Cooperative. A little bit of information about Brian. Many of you may know him already. He has been a speaker at several industry events, and he has authored several articles that have been published by publications in our industry. He has been involved in mechanics and maintenance for over 39 years. I'll just say 40 years. His range of knowledge includes automobiles, trucks, heavy equipment, and power plants. In his early years, he received extensive training in engines, transmissions, gear trains, hydraulics, and pneumatics. And he currently is a predictive maintenance technician with Seminole Electric Cooperative in Florida, where he is responsible for the lubrication and analysis of a combined total of 1,300 megawatt coal-fire powered generation plant. Had to spit that out. Brian holds several current certifications, including CLS, which stands for Certified Lubrication Specialist. He also holds an MLA Level III, Level 1 Infrared Thermographer. He is also a Level 1 Vibration Analyst and a Level 1 Certified Airborne Ultrasound Inspector. With that, thank you, Brian, for joining us today. I'm going to go ahead and pass the controls over to you.
Thank you very much for the introduction, Carrie. I'll say good morning to some and good afternoon to others. And I'd like to thank Test Oil for facilitating these educational webinars and for the opportunity to be a presenter today. As Carrie mentioned, we are going to be talking about condition-based oil changes and an easy way to save big money if done correctly. I always like to start off my presentations with a safety moment because safety should always be your #1 concern when working in an industrial environment, as well as at home, in the public, wherever or whatever you might be doing. You should always be looking out for safety. Always wear gloves when collecting or handling lubricants. We usually know what's in a new lube, even though some of them can cause rashes and irritation, but you don't always know what might have contaminated a used lubricant. So always wear gloves, take care of yourself. Always pay attention to your surroundings. If you've got hot surfaces, rotating equipment, pinch points, things you can hit, things you can trip over, things you might step off of. Just because it was good last month when you pulled a sample doesn't necessarily mean it's good this time. And basically, don't multitask. And finally, the most important thing is that no sample collection is worth an injury or an ounce of your blood. If you can't do it safely, modify it, change it, or maybe it's not worth collecting. I'm not going to read the overview to you, but I will say, as Carrie mentioned, anybody has any questions as we're going, they say the only dumb question is one that's not asked. Most likely, somebody else is thinking the same thing you are, so step up to the plate, type in the question, and we'll be glad to answer it at the end. So what types of oil changes do we have? Well, we have the reactive type. That's the oh my God moment when it looks like a milkshake because you got water in it, or you got foam coming out the top of it because somebody put the wrong kind of oil in it. Even with the best lubrication program in place, you're still going to have some reactive moments and reactive oil changes. We have the preventive oil change. These are your PM, either calendar-based or time-based hourly-wise, usually established by your OEM to err on the safe side. They're a very good use. However, they can be kind of wasteful at times because you may have redundant equipment that may not have even run since the last time you changed the oil in it. And then we have predictive and proactive. This is using all of your information that you're getting out of your oil analysis report so you can do an oil change at the right time for the right reason, and that can equal big savings, once again, if done correctly. So, condition-based oil changes are not to be taken lightly. Now, I'll repeat that again, are not to be taken lightly. You can end up with big cost avoidance or catastrophic failures. Nobody wants any catastrophic failures to their name. You've got to have a champion over your program, somebody that understands all the information on your lube analysis report, not somebody that just reads the manager's reports and goes after the yellow or the red highlighted ones. You've got to really pay attention to how things are working out. Your additives, if they're depleting properly, oxidation levels, acid levels, and such like that. Not all equipment is going to be a candidate for condition-based oil changes. Sometimes you've just got bad actors. There's nothing you can do with them. Sometimes you've got totally nasty environments that no matter how well you seal it or put breathers or anything on it, you just can't get them cleaned up. And very important, if you have any new equipment, always ask if it's under warranty if you can do condition-based oil changes without voiding the warranty. Probably 9 out of 10 times when I've asked, there's usually not been a problem. Sometimes I've had to show them that we had an oil analysis program, some examples of what we're doing, and I always got an email in writing something to document for later down the road if something did happen to happen. You've got to have proper sampling techniques. It's kind of like a computer, garbage in, garbage out. If you don't have good results and good analysis and good information, it's very hard to make good decisions. Some trend information before you get going is always a good thing to have. It'll help you make a decision if it's a candidate for condition-based oil changes. You'll find that you have some equipment that never has any problems. They're good actors. You rarely have any reactive moments. And when I first started doing condition-based oil changes here at the plant, it took me probably about 3 to 4 years to get most of the equipment into condition-based. Start out with a small group of good equipment. Make sure you always get buy-in from your engineers and your supervisors and stuff. Sometimes that's your hardest uphill battle, is convincing them and showing them that this can be done and save lots of money. It helps to know and understand the internals of your equipment and what kind of materials are used in it. Obviously, if you start getting tin showing up, or lead or iron or aluminum, you need to know. It's very helpful if that is something that is within that piece of equipment, so you can know what it is and what might be causing it. And you've got to have a proper slate of oil analysis tests, and sometimes you're going to have to perform special tests periodically to make sure you're not missing anything. Now, I'm going to throw a plug in here to help you out and to help out your oil lab, whether it's on-site or off-site. About every year to 2 years, you should take virgin, unused oil samples and send them out to the lab. Oil formulators like to change things from time to time. And if you're trying to monitor and watch an additive in a lubricant and all of a sudden it drastically changes, if you don't have a new oil sample to reference it to, then you don't really know if it was changed or if you've really got a problem going on. So other things to consider on condition-based oil changes. Obviously, all large reservoirs should be considered. The larger the amount of oil, the larger the volume, the potentially larger savings you can have. However, if you're sampling smaller reservoirs due to criticality of the equipment, an example of that would be our large 6.9 kV oiled motors here at the plant. We monitor those for, sleeve bearing damage or anything else going on. Some of those may only have a gallon per end. However, you've got all the information right there in your oil analysis report. Why not include them as well? Makeup oil and oil additions. Everybody usually has a leaker, something you just can't do anything with. Generally, if you do 25% makeup oil of the correct makeup oil, it's considered to help sweeten what's already existing. Now, obviously, if you've got something that's totally trashed, 25% is not going to do you much good. Quick little side note on that. One of the first cars I had when I was a kid, I put a tank of gas in it a week, and I put a quart of oil in it a week. I never ever changed the oil in it. I just changed the oil filter every 3,000 miles because I was continually changing the oil. Operating temperatures. Temperatures can be a major enemy of lubricants. When you're thinking about temperatures, you got to think outside the reservoir. Just because the lollipop temperature gauge on the reservoir shows 100 or 110 degrees doesn't mean that you don't have localized hot spots somewhere throughout the system. It might be a relief valve improperly set that's got oil screaming over it that's generating all kinds of heat. It might be piston rings on a hydraulic cylinder bypassing that generate a lot of heat. You might have external hot spots that the oil is coming in contact with. And always think about your reservoir heaters. 10 watts per square inch surface area of a heater element is what they consider average for a high viscosity such as a gear oil with a low turnover rate. 15 watts per square inch surface area is what they consider for a hydraulic or a turbine oil, your lower viscosity oils. And don't forget that you may have a sticking thermostat. If your heater element gets stuck on, you're going to have problems with your lube. Temperatures are not a real good friend. Quality of filtration and breather systems. Filters are like anything else. There's cheap ones, there's good ones, and there's excellent ones. If you ever start doing any filtration changes, make sure, once again, you get buy-in from your engineering group and make sure you're talking to somebody that knows what he's doing, because you can change filters and put the wrong one on and actually cause a catastrophic failure. When it comes to breathers, the standard screw-on cap that comes on most reservoirs is kind of like a screen door. It keeps bugs, rocks, boulders, big things out, but not really the problem stuff. Invest some money, go with some desiccant breathers. Not only will the desiccant help relieve moisture, like in the nice southeast where I'm at, but also it'll help keep your headspace dry. And most of your desiccant breathers out there have a 2 to 3 micron filter in them. So you'll actually be filtering the air going in and out instead of just running it through a screen. Now, just because you're doing condition-based maintenance does not mean that you are going to be able to eliminate your preventive maintenance, your PMs. You're still always going to have some couplings to lubricate, some grease points to grease, some pressures to check, some operating speeds to check. There's always going to be something else to do, but you can optimize your PMs. Our PMs originally were listed as lubrication or oil change PMs. Now they're listed as equipment PM or gearbox PM or hydraulic reservoir PM. So optimize them, but you're not going to be able to do away with them because there's still a lot of other things that need to be covered. Talk about a few strengths and weaknesses of oil analysis tests. Laser particle counters, widely used in the industry for particle counting. However, if you get air entrainment or dark oil samples or water that's not caught by the lab, you can get false positives and you can get wrong numbers. Some alternate tests that can be used is the millipore patch test, a wear debris particle analysis, or pore blockage. Spectral analysis, another great tool on oil analysis. It gives you your additives and some of your contaminant metals. However, it's only looking at 4 to 7 micron particle size range. The human eye can see 40 microns, so we're talking about pretty small. Alternate tests for this, you can use acid or microwave digestion, which will dissolve or break down the larger particles into a particle size that spectral analysis can see, or you can do analytical ferrography. Analytical ferrography is an awesome tool. You will end up with particles. You have a good analyst that looks at them. They can tell you if they're cutting or rubbing or scraping, or if they're new or if they're old, by doing morphology on the particles on the slide. So a very good tool to use, even if you're not looking at other things, but you want to know what's going on wear-wise inside your equipment. Water, is another major enemy of lubricants. The standard quick test, of course, is a crackle test or an FTIR. Now, I do know some lab techs that can get pretty on the spot with ppm or percent water with a crackle test. However, just knowing it has water in there in a ballpark is not really great information. If you need to know exactly how much water you have in it, you get a Carl Fisher titration done. Different oils, of course, we have dissolved water, emulsified water, and free water. Different oils can have different levels of dissolved water, and Carl Fisher will show the dissolved water on top of the emulsified and free water. But the point being, certain equipment may be important to get the water out, certain equipment may be critical to get the water out. So if you need to know exactly, get Carl Fisher done. All of my lab analysis, if it has a positive crackle, it gets a Carl Fisher done automatically. That way I've got a number in front of me so I know actually what the water level is. False positives. Silica. Obviously, if you work in a large mine or you're used to seeing silica show up on your oil analysis, you're pretty standard with it. If you don't ever see silica show up on there, then you have a big jump. Or if you have some place where you have silica showing up and you have a big jump, you also need to be looking and thinking about what possibly might have been rebuilt and somebody used silicone or RTV sealer as a gasket material, because that will give you a false positive of silica. Copper is another real common one. This also is about knowing the internals of your equipment. If you've got copper showing up, but you don't have brass gears or brass thrust washers, it might be a cooler. ZDDP in AW hydraulic oils is noted for leaching copper from coolers. Large diesel engines, I've seen this quite a bit. One gets rebuilt. Of course, it's got a nice new shiny cooler in it. The first quite a few thousand hours, you'll end up with copper showing up in there because the ZDDP in your engine oil is actually leaching the copper from the cooler. So be aware of false positives. And then having somebody to ask at your lab, whether it's internal or external, about specific test limitations or alternate test methods is a must. If you've got that gut feeling that something is going on, something's wrong, something just isn't right, you really need to have somebody to ask about an alternate test that will either prove it's right or disprove it as not being good information. These are some of the special additional tests that might need to be run while you're doing condition-based oil changes to make sure you're not missing anything. Your rotating vessel pressure oxidation test, the ruler, and the total oxidation stability test. These three compare a new oil, known value, to your used or current in-service oil to give you an idea where your used oil is at in its life expectancy, how much you've got left on it. Varnish potential, which is your MPC, your QSA, or your VPR. MPC being the ASTM method, the QSA and VPR were very similar methods. Air and foam, we both know that air is not a good lubricant. As an oil ages, this could become an issue, so it's something you need to keep an eye on if you're extending your life. Demulsibility. Most industrial lubricants are designed to demulsify or separate water. Therefore, you can drain a little bit out of the bottom of the reservoir. Unlike engine oils that are designed to emulsify a little bit of water. I'm not talking about the blown head gasket milkshake looking engine oil. I'm talking about the little bit of moisture you get every time you stop your engine and it goes through dew point. That little bit of water will actually get hot enough in the oil to boil out. Rust and copper strip. These are corrosion tests. Total acid number, something generally associated with industrial lubricants again. Once it's doubled over the base, it's usually considered time to change it. Base number, something that's usually associated with engine oils and helps neutralize the acids that are part of the combustion process. Now, this is something that my oil lab turned me onto a couple years ago on my large diesel engines of running acid and base numbers. The base, you can see how it's depleting and being used up, neutralizing the acid. And the acid, you can actually see how it's increasing and give you some more guidance on when you need to change your oil on your large engines. And then, of course, for Carl Fisher, we talked about that. When you need to know an exact water amount, get a Carl Fisher done. So now we're going to talk about the actual versus the real cost of lubricants. The actual cost of a lubricant is what you pay the distributor per gallon, pound, pail, drum, however you receive it. Industry average cost for mineral oils is $9 to $14 a gallon. Now this was a highly scientific survey that I conducted. I called 3 friends of mine that are lubricant suppliers and got price ranges and came up with that. Synthetic oils, $20 to $30 a gallon, and specialty synthetics can be $60 or more. Talk about specialty, we're usually talking about fire-resistant fluids and some of your silicone-based lubricants. So for discussion purposes, we're going to say $10 a gallon for mineral oil, $25 for synthetics. Now we'll talk about the real cost of a lubricant. This is the total cradle-to-grave cost once it hits your facility. Receiving, storing, dispensing, installing, and disposal. So the time it comes on till the time it leaves. Now there was a NORIA article several years ago, and I'll date myself because the magazine was still called Practicing Oil Analysis before it became Machinery Lubrication, that stated the average cost was 4 to 7 times per gallon and up to 40 times per gallon for contaminated oil such as radioactive. Now I've tried to calculate this a couple times, but it's very difficult because just because an oil change takes 15 minutes this time doesn't mean it won't take 3 or 4 hours next time with lockout, tagout goes wrong or a valve doesn't work or something. So it's really hard to calculate and figure out. But since this is an old article, I generally go with 7 times cost per gallon. So for mineral oils, we're looking at $70 per gallon, and for synthetics, we're looking at $175 per gallon. Now remember, this is the total cost of the installation, the receiving, the storing, the whole package of it from the time it comes on plant site till the time it leaves plant site. The facility, as Carrie mentioned earlier, we were commissioned in the early 80s, back when coal was king. It is a 2-unit, 1,300 megawatt combined cycle or combined facility. We've had all of the emissions equipment that was available back in the 80s, and since that time we've added everything that's available with the exception of carbon capture. Carbon capture is not the problem. It's what to do with it once you catch it that becomes the problem in a large facility like this. On the chart, on the left side, you'll see the equipment group. We've got large motors, compressors, blowers. Now this is all the blowers, all the compressors, all the oiled motors on site. The next column over would be total gallons. That is how many gallons all of each one of those equipment groups carries, for total gallons of 6,043 gallons. Next middle column would be previous service frequency, whether it was done yearly or every 6 months. And if you look at the bottom there, you'll see that the gallons increases to 7,948 gallons based on twice a year or once a year. Under the next column, average drain frequency. This is what's been achieved with condition-based oil changes, which were pretty much the final implementation, except for new equipment, was in 2005 here at the plant. So we've been using it for over 10 years. 5 years on quite a bit of stuff. Some things are 1.5 to 2 years, 1 to 2, you know, it varies. And this is average. Every now and then there's still going to be that reactive moment of something happens, it's got to be changed. Actually, some of the fan reservoirs and all, we're actually pushing 8 years on some of those now. They're, you know, a low-stressed environment. On the right is the sample frequency, whether it's quarterly or monthly. Sometimes, even though quarterly, you may think of calendar time, I go on hours because, once again, with redundant equipment, you may not run it. So 2,000 hours is roughly 3 months, a little bit under. But it's easier that way you can actually do it by hours instead of pulling a sample on something 3 months down the road that might have run for 20 hours. And then you'll notice a note at the bottom. It talks about turbines, boiler feed pumps are not included in this. That's a total of 20,200 gallons between the 2 units. And then turbine control oil, that's at $60 plus a gallon. There's 4,800 gallons of it. And those we're actually getting condition-based oil changes before we ever even started the oil analysis program proper here at the plant. The lubricant manufacturer would pull samples once or twice a year and deem if it was still good for service. To date, we have not ever yet done a turbine total oil change out yet. And the turbine control oil was just done a couple years ago after 30 years. So let's talk about the money. The perfect world scenario, which we know doesn't exist, no oil changes for 1 year. But if it did, we can all dream, right? Under the previous change frequency, we had 7,948 gallons times 70. You're talking $556,360 of savings or cost avoidance per year on the equipment that was listed on the previous slide. Under the 5-year achieved oil changes, so you're deferring 4 to 7 oil changes, that's 18,145 gallons times 70. You're talking almost $1.3 million over a 5-year time span. And some of this stuff is extended into 8 years now. So there's quite a bit of savings available there. And of course, like as mentioned on the other page, the very large reservoirs are not included in the calculation. So what's our return on investment for condition-based oil changes? On the previous slide, we had 792 samples per year collected on the condition-based oil change equipment at an average of $20 to $40 per sample analysis. Now this is another one of those highly scientific surveys. I called up 3 or 4 people I know that run oil labs and asked them their average price. So at $20, we're looking at $15,840. At $40, we're looking at $31,680 for the cost of the oil analysis per year on the condition-based equipment. Salary of a person running the oil analysis program. I know that magazine maintenance technology usually does a survey once per year. I think machinery lubrication did one a while back. And they said that an average lube person running a program at a plant was $65,000 to $85,000 a year. So let's say $80,000 per person, rounded up to $32,000. We're going the high end for oil analysis cost. You're looking at $112,000. Throw in another $60,000 for your personal package of insurance, if you're lucky enough to have that, and other benefits that you have, your benefit package. You're now talking $172,000 a year. Most likely, you already had the oil analysis program established before you started doing condition-based oil changes, so you already had that cost. So, should it actually be considered a cost? Or with everybody wanting to cut out programs and downsize nowadays, should you be promoting it as a justification to help fund your oil analysis program? $172,000 is significantly less than $556,000 savings per year. So use it to your advantage and promote your program. Some additional benefits of condition-based oil changes. Obviously, we'll have reduced environmental impact because you aren't going to be requiring any new lubricants. And you're obviously going to have reduced disposal of used lubricants. You're going to have reduced human intervention. Anytime you get meddling fingers, start working on something, there's always the possibility that something's left out or something's not right when you get done with it. Freed up man hours, the hidden workforce, to perform proactive work on equipment that needs it. Now instead of however many people doing arbitrary oil changes based on PM needs, those people and their hours can be used on equipment that needs to be worked on to help you get things more reliable and make them last better. You have reduced cost of unnecessary filter and breather changes. Under some of our old PMs, even though it was a duplex filter, they only needed to service or change the one that was in service. The other one was never used. They would change both filters on it. So now you're throwing out a filter that wasn't at its full capacity yet, and you're throwing out another one that had never been used. And some of these filters we used to change are $200 to $300 a piece. When it comes to breather changes, sometimes you might do a little bit better, sometimes not. And always remember, if you don't have a duplex filter set up, well then if you got a PM, well you might need to change the filters just to be on the safe sake so you don't have to worry about taking the equipment back and taking it out of service to change a filter on it later down the road. So always use common sense with this as well. You've obviously got less chance of the wrong, incompatible, or worst case scenario, no lube being returned to the reservoir. Reduced sediment stir up in the sump. Remember, the sump has basically three purposes: cooling, air release, and sediment settling. If you change the oil, the best time to do it is when everything's hot. Well, normally with lockout tagout procedures, that's kind of rare to happen, to catch something when it's hot. Now you drain the oil out of it, you pour new oil in, and it goes down to the bottom and stirs up all the sediment that's been laying there minding its own business in the reservoir. And now you've got something that either has to be filtered back out or something that's going to have to settle back into the reservoir. But don't be surprised if you start doing condition-based oil changes and you're not opening up a reservoir, once a year, twice a year, that you don't start seeing some layup and some stuff in the bottom of the reservoir. But that's the purpose of it. It settles. Your suction and pickups are usually up off the bottom, so they aren't going to pick it up. It's not going to be an issue. And then you could have a possible reduction in failures or infant mortality, once again, because you're not introducing the human error factor. Anytime people start messing with stuff, sometimes the results aren't the best. So instead of just lying around doing nothing, why not try to stand out in the crowd? And you can start working together to create your own cost avoidance and possibly save your company a fair amount of money as well. So with that, I'll close with a quote. I don't think we get smarter as we get older. We just run out of stupid things to do. And I think we should be open for questions. Carrie, turn it back over to you.
Well, I love that picture. That's hilarious. I guess all of your pictures at the end just made me laugh. So if anyone has questions, please use the question toolbar. I have had several people ask me already when I was going to be sending out the presentation. Typically what I do is send out a link to the recording, and then if anyone wants the slides, I will get it approved by Brian, and then I can send you PDFs of the slides if that's something you need. So far, those are the only questions we have. If also, when I send out the recording, you'll receive a survey, and there is an opportunity to submit questions through the survey, and those will also go to Brian to answer. So with that, I'm going to go ahead and wrap it up. Thank you so much, Brian. It's a pleasure having you, doing our first webinar with you, and hopefully we'll do some more in the future.
Well, thank you very much for the opportunity. I appreciate it.
All right. Take care, everyone. Bye-bye.